Alright, welcome back. I said in the last video I was going to do some more practice problems. So right now we're looking at number 16 on page 18. This is the practice, but we aren't going to do this practice for homework, so we'll do it for a practice problem. So we need to highlight the lines that are parallel. So here we say AD is parallel to BC. Our first step should always be highlight or color in the parallel lines. That's on our yellow paper for our tips for how to do two-column proofs. And now that we know what we're looking for, the only thing that we use with parallel lines has been and will always for this section will be alternate interior. So we need to form that Z by coloring in the transversal as well. And now we know that we were given that the lines were parallel. And now if we look at the corners of the Z, they say that angle 2 and angle 3 are congruent. So that's exactly what we have written out. And I don't know why they give us this many lines, because we can just say AI for alternate interior, angle symbol, theorem. We do not need all these lines. So that means these two angles are congruent. The next steps say the next thing is given. So if we look back up at our given, it says AD is congruent to BC. In our picture, let's add that. We need a tick mark on AD and a tick mark on BC. Next thing that they say, BD is congruent to BD. If we look at our picture, BD is right here. BD is also right there. So because it's the same line, that should always be the reflexive property. So we have congruent, congruent, congruent. We have our three pieces that we need. If we look at this, if we can't ever see what acronym it is, it helps to just draw one triangle. So we have a side, an angle, a second side. If we travel around the triangle, we get a S, an A, and then a S. So this would be SAS, and we can just copy the proof statement. So that's ABD, triangle ABD is congruent to triangle CDB. So that's how we would fill this out. We could then use this flowchart proof to write one of our other proofs. We can do a two-column proof. This would just be row 1, row 2, row 3, row 4, row 5. If we did it as a paragraph, it would be sentence 1, sentence 2, sentence 3, sentence 4, sentence 5. We're going to skip 17 and 18, and we're going to jump right to the pages for 12.2. There's nothing new in this section. It just kind of has us go in and practice more. So if we look at number 1, it's just asking us to write a paragraph proof for this. Again, in my opinion, a paragraph is a very daunting thing to write if you don't have a two-column or a flowchart proof already made. You could do it first if that's just what comes naturally to you. You should still be marking up your diagram first. So it says MA is parallel to HT, which means we can form the Z like this, which means these two angles are congruent. They also give us that MAT is congruent to THM, which would be that, and then we should see that there's a side in common. So here is this. So when we look at this, remember we're doing this before we write the paragraph, we have an angle, then a side, so this would be AAS. And then lastly, it wants us to prove that those two sides are congruent, and whenever we already know that two triangles are congruent, all their parts have to be congruent. So we could try to write the paragraph first, and it would look something like this. We know, so we were given MA is parallel to HT, which by the alternate interior angle theorem, or you could just even say, because we know alternate interior angles of parallel lines are congruent, that means angle, and we do have to use the full name here, so angle AMT is congruent to angle HTM. Next, we were given angle MAT is congruent to angle THM. We had nothing else to do with that, so we can move on, and then you can say by the reflexive property, we can say MT is congruent to itself. the book likes this word therefore, which just means based on all previous evidence. Therefore, triangle, and then if we do AMT, the name of the second triangle should be HTM. Therefore, triangle AMT is congruent to triangle HTM and we already said it, by AAS, and we could say congruence criterion or congruence theorem. That's it for proving the congruence. Then we need to say by the definition of congruent triangles, we would know all corresponding parts are congruent, and MH and AT are corresponding parts. Are congruent because they are corresponding parts. We actually don't need this part right here, but I thought it would help some people understand it. So you could do this first. It just seems to me like you're just writing a flowchart or two column proof together. The book makes it seem like it's more of like a brainstorm, but it needs to be just as detailed and correct. So it needs not just a way to think about it, but actually thought out and make sure it follows. So if we look at the flowchart proof and just want to fill it in, first we said this line segment MA is parallel to TH, that was given. This is number 2 now in the book. We had angle MTH is congruent to angle TMA, and that's because they were alternate interior angles. And we have a whole theorem for that, so again, I don't know why it gives us that much space. We were given these two angles were congruent. And then lastly, we used our reflexive property to say these two line segments are congruent. You could also say congruence is reflexive. We then said our two triangles were congruent. So I think the book used different names for the triangles, but that's okay. There's 8 different ways we can write line 5 and still be correct. And we said AAS. And then lastly, this is what we were asked to prove. And that was, again, by the definition of congruent triangles, which we could also write it as CBTC, which means corresponding parts of congruent triangles are congruent. Again, if we wanted to write this as a 2-column proof, we could. It follows the same order. So we have MA is congruent. No, I always want to do this. MA is parallel to TH, and that was given. Whenever we see parallel lines, we should be using alternate interior angle theorem next. And that was that angle MTH is congruent to angle TMA. Next, we were given 2 more angles were congruent, MAT and angle THM. Next, we could use the reflexive property to state MT is congruent to MT. Then we used AAS, or I guess you could say SAA, to say triangle MAT was congruent to triangle DHM. And then lastly, because of the definition of congruent triangles, we can say that those 2 side lengths, because they're corresponding parts, are also congruent. So that's the work there. We just did all 3 proofs, well, all 3 versions of the proof for that practice problem. If we look at the homework, the practice from the section, which might have been homework, but again, we have the sub work. It's just asking you questions, not really to do proofs. Oh, number 8 is a proof. If we look at 6, though, it says, if the first statement is a flowchart proof, BX is the bisector of ABC, then which one of the following, this is what your quiz might look like. So if we draw the angle ABC and then draw BX, we can look at this. ABC is the big angle, XBC is half the angle. So this is wrong because one's half of the other. ABX plus XBC should add up to ABC. That might work out. ABX is congruent to CBX, which checks out. This does not. So then which of the following? So this one has two correct answers. All right. One is more useful than the other. So this one is way more useful because we are always looking for congruence when we're doing these proofs now. Although B is correct, that's much more useful when we're trying to figure out how big an angle is. But if we're doing triangle congruence, like if we had the side AC, that would be far more convenient for us. Answer C. 7. Which theorem or definition justifies the statement if E is the midpoint of AF, then AE is congruent to EF? So this one's kind of a weird one. We see a vocab word, so again, this is going to be definition of midpoint. So you might have been thinking a bit more complicated than that, but it is just the definition of the word that they used. If we look at this given in proof, we won't do a proof, but we'll talk about it. So CD bisects AB. So that means E is the midpoint of one of these two sides. So we have to remember the second thing is what's getting cut in half, so we can add our tick marks. They say AB is congruent, A is congruent to B, so we can add those in. We need a third piece of information. I think back to my three culprits. We have vertical angles, we have alternate interior angles, and we have reflexive. The only thing I see here is this bow tie. So we have vertical angles, which means we have ASA. And that is one of our criteria. So that's how we would have to do it. Just lay out our proof that says we were given that CD bisects AB, which by the definition of bisects means that AE is congruent to EB. We were given that angles A and B are congruent, and then we could use the vertical angle theorem to state AED is congruent to BEC, which is going to prove us through the ASA congruence criterion that those two triangles are congruent. So hopefully that helps out if you're a bit confused. Again, we'll have a quiz on Tuesday that covers all congruences, so chapters 11 and 12.